Assalamu alaikum. I am Awam and in this video I will explain processor architecture and performance. I will try to keep it very simple so that you can understand it easily. I am going to talk about what a processor core is, why it matters for multitasking, the difference between single core and multi-core CPUs, and finally I'll show you an example from my own computer to see if it can handle tasks like video editing, virtual machines, or just normal browsing. Let's get started. Now first we have the topic understanding the processing core. So what exactly is a processor core? Think of it like a worker inside your computer's brain. Each computer or core can handle its own set of instructions. The more workers you have, the more tasks can be done at the same time. This is why modern CPUs don't just have one core anymore. They often come with 2, 4, 8 or even more cores. This helps your computer stay responsive even if you are running multiple apps or doing something complex like editing a video while browsing the web. Now we first talk about the single core processors. Early computers had only one core. That meant the CPU could only handle one instruction at a time. It could switch between tasks really fast to make it look like multitasking, but true parallel execution wasn't possible. For their time, single-core processors were revolutionary, but they struggled with demanding apps. Imagine trying to run YouTube, Word, and Spotify at the same time. It would lag badly. That's why they were only good for simple things like typing documents, basic spreadsheets, or casual old-school games. Now we see that we are advancing with dual and quad-core processors. And then the next big step was dual-core processors. Within two cores, computers could finally handle real multitasking. You could listen to music while browsing the internet and everything stayed smooth. Then came quad-core processors. With four cores, these became the standard for laptops and desktops because they made heavy tasks like gaming, photo editing, and using more advanced software much smoother. Basically, dual core was like having two workers, and quad core was having like four workers. No, we can say that quad core was having like a whole team. Now we see that now is the era of octa core, which is 8 cores, and it is going even beyond that. Now we also have octa core processors which have 8 cores. These are designed for serious multitasking and demanding workloads. For example, if you're editing 4K video, live streaming, and still running background apps, an octa-core processor keeps everything running without freezing. And in high-end systems like servers or professional workstations, processors can have 16, 32, or even more cores. These are used for things like data centers, scientific simulations, or training artificial intelligence. So the trend is moving towards more cores and smarter designs to keep up with the modern software. Now, here's something funny. Let me tell you about my processor. Now let's take a look at my own computer. I open the task manager and check the CPU tab. My processor is an Intel Core i7 6th generation. It has a base clock speed of 2.2 GHz. And as you can see, it has two cores and four logical processors. This combination gives a balance between multitasking power and efficiency. It's not the most powerful CPU out there, but it's definitely capable of handling day-to-day tasks and some basic tasks also. Now we see the key processor metrics. When looking at processors, three main things matter: the core count, clock speed, and logical processors, which is also called thread. The core count is that tells you how many physical workers you have. You can think of the clock speed, which is measured in gigahertz, which shows how fast each worker can complete instructions. And as for the logical processors or threads, which can you can think that they can make better use of each core. The right balance of these three is what makes a CPU suitable for different kinds of tasks. Now we see the suitability for video editing. High resolution video editing is one of the toughest jobs for a CPU. Rendering and applying effects in 4K or 8K video requires both a high core count and high pair threading. My processor with 2 cores and 4 threads can handle editing, but it won't be as far as a higher end CPU with 6, 4, or 8 cores. So it is possible for light video editing. Now, if you go on the topic of virtual machines, running a virtual machine means simulating a whole computer inside your computer. That needs a lot of resources because the host system and the virtual system both demand processing power. A 2-core with hyper-threading like mine can run a virtual machine without too much lag, but if I tried running multiple virtual machines at once, performance would drop. RAM and storage speed also matter here, not just the CPU. Now we see the suitability for browsing and office work. For basic tasks like web browsing, using Word, Excel, or PowerPoint presentations, my CPU is more than enough. In fact, even a dual-core processor could handle these everyday tasks. So, for office productivity, clock speed and core count aren't as critical as they are in heavy workloads. So to wrap up, a processor core is like a worker, and more cores mean better multitasking. The balance between core count, clock speed, and threads decides what your computer can and can't handle. My CPU is good for everyday use, fine for running a virtual machine, and decent for video editing, but not as powerful as high-end processors used by professionals. Thanks for watching, and I hope this helped you understand processor architecture and performance more clearly. Thank you.